Welcome to the Stratus Works product overview. Stratus Works bridges the gap between engineering design documentation and actionable fabrication, helping electrical contractors prepare model designs efficiently. Our solutions enhance Revit's functionality by seamlessly integrating design, modeling, and fabrication processes. We are going to start by showing you conduit efficiency features. We begin with the Select Connected feature, which allows users to select an entire conduit run or multiple runs, serving as an advanced alternative to Revit's native tab select functionality. To use this feature, we just select a set of conduits and hit the Select Connected button. All connected components of the run, including the conduit run element, will be highlighted and selected. This functionality streamlines the selection process and ensures you can work efficiently with connected conduit systems. Next, the Connect Offsets feature, which helps quickly connect parallel conduits using a list of standard bend angles. To do this, we select any two conduits that are parallel to each other, initiate the feature using a keyboard shortcut, and select the desired bend angle. This feature ensures consistent offset creation, reducing manual effort and errors. The Conduit Cleanup feature automates data synchronization across connected conduit networks and updates the conduit run schedule as well. To do this, we can select any set of conduits, enter a value into a mapped parameter, and apply those changes. That value will be automatically propagated to all connected conduits in that network, as well as pushed to the conduit run schedule. This automation reduces tedious manual data entry and ensures accuracy in your schedules. Now, to go along with that, the Clear Values feature allows users to remove data from those mapped parameters with a single click. We are going to select these conduits and use our Select Connected feature and then hit Clear Values to watch those values disappear. The Schematic Viewer and the Feeder Schedule Import feature allow you to map feeder schedule columns in an Excel document to Revit parameters for use in imports and exports from the Revit model. Part of this process ensures system designs align with project requirements, as well as allows a QA/QC operation in accordance with that engineering design. What we see on the right here is a simplified single-line drawing that's derived from that feeder schedule. This tells us equipment that we need to connect to, whether or not that equipment is in the model, and when those connections have been reconciled with the feeder schedule. As we build out this system, we will see that the Schematic Viewer tells us what run IDs need to be populated in these conduits. We can start by initially applying a value. These don't yet match the values from our feeder schedule, but we are going to fill them in here. What you will notice is that as we applied a feeder ID, it was used as a lookup value from the feeder schedule that then imported additional property data like from, to, material, and wire data into the conduit runs that will be used later. You can also see that those connections have been reconciled in our Schematic Viewer. They show not only that these are connected, but the conduit lengths and the circuit lengths, which derives a length from the conduit as well as a wire makeup value at each connection point. This also tells the overall change in bend angle as we propagate through those runs. Now we are going to go fill in the rest of this system. What we can see is that the schematic reconciles our model design against our engineering design intent, showing us a 100% completion status as we complete that final conduit connection. We can also see that our conduit run schedule has been fully populated with all the relevant data. The next part that we want to cover is a validation of our wire pull calculations. This is going to show us all of our various wire pulls. We can see that we have a failure in this run, and we can even analyze and see from which part we initiate that failure. Pulling through this elbow initiates a failure. Some of this can be controlled through our wire pull calculator settings. We can tell that we've got a fairly high coefficient of friction applied to my wire pull calculator. We are going to drop that down to something more reasonable and rerun my calculations. Here we can see that we've got acceptable wire pulls throughout our entire system, and we can begin preparing this model for fabrication. Opening our dockable conduit splitting palette, we can see a number of features. One of those features allows us to simply align couplings. We can select a conduit, initiate the native Revit splitting feature, and place 2 different couplings. Now once we select those, we can initiate our Align Couplings feature from this window or directly from the ribbon above. We select the coupling that we want to align to, and it pulls all other couplings in alignment with it. The next feature is our Decouple Run feature. When we delete couplings from a Revit model, we can see it just places a gap in there, but sometimes we want to repair those. So instead, we will select them and use the Decouple feature, which heals those conduits and removes the couplings. Now we are going to begin splitting. Since this is an underground system, we are going to be using bought-out fittings and straights between them. Here we can see we've got several splitting features. The ones on the left are for splitting single conduits. The ones on the right are for splitting multiple parallel conduits. We can split just the next set of couplings, all couplings until we reach a fitting, or the entire conduit run. We are going to change my stock length to 20 feet and initiate the Split to Fittings feature. Next, we are going to move on to my overhead conduits. We are going to split the run, but we want to approach this with a different stock length, so we will apply 10 feet in my settings. We will go in, Split Run Multiple, and place our couplings. We can validate the length of this selection with our Conduit Lengths feature. That's going to tell us that this one is 8 foot, 11 and 5/8 inches, and this one is 10 feet. Now we will begin splitting these, and we will move throughout the rest of our run. Since these are just single conduits, we can initiate our single split feature. It will place couplings, and now we've got a fully defined and fabricatable conduit system. The last thing we want to do is generate conduit bin sheets. But to do that, we have to give each of these conduit segments a unique name. Luckily, we had auto-numbering turned on when we ran all these splits, and so the conduit section name property is already populated. That gave a unique value to each of the conduits as we propagated down a run. Lastly, to generate bin sheets, we have to open up our Data Manager feature. Opening that, we can see sort of a simplified conduit run schedule. We can take a look here and see all of the various segments that are involved in this set of runs. And if we wanted to generate bin sheets for everything here, we can. Select the conduits in your model, click this button that says Check with Bins, and it is going to find all conduits with bins in the table based on my selection. Let's generate some bin sheets. We are going to isolate a specific bin out from our model, MV-105. We are going to open that text file and see our bin instructions laid out here. The instructions read that we have 2 bins. The initial mark is 1 foot and 3 inches off of the edge of the conduit. The next is 5 foot 2 and 7/8 inches from the edge. We will place those marks, make our first bend at 30 degrees. Then we push the conduit to the next mark, rotate 180 degrees clockwise, and make another bend at 30 degrees. These bin marks are configured in Stratus Works to match to a reference location on your conduit benders. Thank you for watching this Stratus Works overview. These features empower you to streamline your workflows, enhance your productivity, and deliver exceptional results on your projects.